Now we need to talk about area and the area of various shapes. If I were to, for example, draw a rectangle, which we talked about last week, it's got parallel sides and all the angle measures are 90 degrees, so a bunch of right angles and so on. So if I were to talk about the fence, it would be, and that was perimeter. We talked about that last week as well. Perimeter was the length of the line that goes around the outside edge of the rectangle. That was perimeter. And as we switch to area, now we're talking about all the stuff inside. So how much grass would you need, for example, to fill the yard that you just fenced? And we've got a collection of formulas to calculate area. They're varied, but in general, we just need to find some lengths. Maybe I'll call that side L for length and this one W for width. And if maybe we said length of this particular rectangle was 3 and the width was 2, then I could divide this length side into thirds and divide the width side in half, and we can see that I end up with 6 shapes in here. So it's as if we have, say, 2 rows of 3 each, or 3 columns of 2 items. And that's basically what we're talking about with area. The area of a rectangle is just length times width, which makes it a bit easier to calculate. I mean, just multiply a couple of numbers together. Now, if what we have is a special kind of rectangle where all the side lengths are the same, which we call a square, then of course, length and width are equal. So our area was from a rectangle, length times width, but if length equals width, we could replace that second, well, the first W with an L, so it's L times L, which is L squared. And that's actually how we came up with calling that a square when you raise something to the second power, because we are finding the area of a square. Now it's most common that rather than calling that length and width, because one's not longer than the other, we just call them sides. So rather than having length times width, we've now got side times side, which is side squared. So you can get the area of a square just by taking one side and multiplying that length by itself. Of course, we've got some other shapes, but let's kind of work our way through that. I've got a couple of problems here that'll help us solve those. So maybe we've got a pathway like this, and they give us some lengths, and we need to determine how much area is in this path. Well, we've got a couple of options here. Notice that the full area is not a rectangle. We could potentially split this so it was 2 rectangles. And now we could find the area of rectangle 1 and the area of rectangle 2 and add those together. So the total area would be the sum of the 2 sub areas. Well, area 1 would be length and width 1 multiplied together, and area 2 would be length and width 2. So the length of rectangle 1 is 13. The width of rectangle 1 is 3. Length here, width there. And then we will add that to the length of 2. Now, I don't really have the length of 2. I've got this length of part of it, but the whole rectangle itself is that long. So I've got the 6 down here. Of course, that's a 3 if this is area 1 is a rectangle. So maybe 6 plus 3 would give me the total length of this one, which is 9 feet. And the width of area 2 is 3 as well. Well, 13 times 3 is 39. 9 times 3 is 27. If I add those two together, I get 66 square feet. Remember when we were talking units, how we could calculate area units and we would have a length squared. So if you've got an area, make sure your unit is some length squared. We do have some other units like acres and so on that don't have a square, but oftentimes we will have a length squared. Now, like I said, we have a couple of options here. What if instead of dividing that into 2, we extend this down and make a great big rectangle, and then we'll just subtract this portion that is a hole? Well, we can certainly do that. The area of the total is now the area of the large rectangle minus the area of the shade. So the large rectangle now has a full length of 13 plus 3, which is 16 feet. And we've already calculated the full width, so that would be 16 times 9 minus the shaded region, which is 13 times 6. Well, 16 times 9 is 144. 13 times 6 is 78. And 144 minus 78 is actually 66. Just like the other one. So we've got a couple of ways we can approach area problems. We can split it into simple shapes that we know and add up those simple shapes. Or we could say, well, this also kind of looks like one big shape that we've taken a hole out of. And so we can take the big area and subtract the area of the hole. And sometimes we'll do exactly that. Let's take a look at another problem here, where we're asked to find the cost of carpeting a floor measuring 12 feet by 15 feet. So if we've got that floor, and we'll assume it's rectangle. Oh, it's no assumption. They told us it was rectangle. 12 feet by 15 feet. And they give us a cost per square yard. Well, it'd be awful nice if we had those in yards instead of feet. So let's do some conversion here. 12 feet, and I know that not 1 foot, 3 feet is 1 yard. And now feet will cancel because feet divided by feet is 1. I multiply across the top, 12 times 1, divide by 3, and I have 4 yards. Remember, we did this dimensional analysis with our unit conversions. I can do the same thing with the 15 feet. I know that there are 3 feet in 1 yard. And again, I put the 3 feet on the bottom so that the units would cancel. I have feet in the top and feet in the bottom. Feet divided by feet is 1, so those cancel. And I'm left with 15 times 1 divided by 3 is 5. And the only unit I have left is yards, and that's in the numerator like I want. So 12 feet is 4 yards. 15 feet is 5 yards. So now I can find the area is still length times width. So that is 5 times 4, which is 20 square yards. And if I've got 20 square yards and the cost is $18.50 per 1 square yard. Now look at that, my units cancel. I'm left with just dollars, so I have 20 times $18.50, which would be $370. So we can notice this wasn't a dimensional analysis down here in the bottom, but that same setup can apply to help me know whether I'm multiplying or dividing. Just really pay attention to those units. But this was an area problem. And we did a conversion so that it was in the units that matched the price. And then we just found the area of the rectangle and multiplied that by the cost per square yard. So the area, again, comes in handy here. Well, we don't just have rectangles. We've got some other shapes. So let's take a look at some of those. Maybe I've got a parallelogram. Well, there's a parallelogram, so the two opposite sides are parallel. It looks kind of like a rectangle that got skewed. Well, take a look at this. If I were to cut off that triangle right there and bring it around to here, now I've got a rectangle. Notice this outside edge makes basically a rectangle, and that can help us determine how to calculate the area of a parallelogram. The area of a parallelogram is what we say is base times height. So where we had length before, now that becomes our base. And the height is this perpendicular distance between the two bases. And it's not the length of the side over here, it's the perpendicular distance between the bases. You can see that that becomes important when we really skew this parallelogram. Now that area is really small compared to what we had before. So it becomes really important to note that it's that height right there that we're multiplying by the base to get the area. So not so much the side there, but the height or the distance between the two parallel lines gives us the area of a parallelogram. We could do something similar with a triangle. Say we had a triangle like this. We pick up that triangle and kind of flip it over. Now we've got a parallelogram. And so let's do something similar. This is our height. This whole distance is our base. But notice we've eliminated that half of the parallelogram. So the area of our triangle is half the base times the height. And you have these formulas on the formula sheet, so you don't have to memorize all of them, though I suspect some of them you already have memorized, just because you've heard them through your lives. But it's nice to see where some of these come from and to know that you can always create one like that. There's another shape here that we need to understand, and that is a trapezoid. A trapezoid, we talked about last week as well, is a quadrilateral where we have two parallel sides on opposite edges. And yet to calculate this area, it's again kind of odd, but seems like I ought to be able to take that triangle and bring it over here. But unfortunately, trapezoids don't always line up that way. However, if we took half of that, halfway between the two bases, and trimmed that triangle and brought it up here, and trimmed this triangle and brought it up here, now we're back to a rectangle shape. But I see this length of the rectangle is a different shape. But notice it's halfway between the top base, we'll call base 1, and the bottom base, which we'll call base 2. So how do I get kind of that number that's exactly halfway between them? We take the average, and to take the average of two numbers, you add them together and divide by 2. So that's our new length, is the average of the two bases. We still have this height between there, so we'll multiply that by the height. And that gives us the area of a trapezoid. We usually write it 1/2 the sum of the bases times the height. Now in the book, I think they call this A plus B. I don't like that so much because A and B aren't as well delineated as base 1 and base 2. But regardless, you're going to add the lengths of the two bases together, divide that by 2, take the average of those two, and then multiply it by the height. And that will give you the area of a trapezoid. Let's see, are there any other shapes we'll want? I think there is. Another shape we've talked about. We didn't talk about it much last week because it's not a polygon, it's a circle. And there are some features of circles that we'll take advantage of, like this distance from the center of the circle to anywhere on the circle is a radius. The plural of that is radii, so you might hear that. As a matter of fact, if we take 2 radii and line them up end to end and go through so it goes through the center, that is a diameter, which we will use. Now, since we didn't talk about circles last week when we did polygon, we need to talk about we didn't talk about the perimeter because it's not a polygon, so we didn't talk about that length around the outside edge. But the length around a circle has a very particular name. It is called the circumference. And it has a calculation. With perimeter, we just added up all the sides. For circumference, it's 2 pi r, which, remember, 2r make 1d, so we could also call this pi d. That gives us the length around a circle. Now, pi is about equal to 3.14, which you can use in your calculations. You may have a pi button on your calculator, and you can use that as well. But if you don't have the pi button, you can just substitute 3.14 for pi. Now, the area of a circle, again, takes pi into account. It will be pi r squared. So notice here we're squaring the radius, so that gives us our length squared. Up here in circumference, we're not squaring anything, so this is a length unit. So we won't have any squared terms. The area, we will have a squared term. So you can think about that when you're using formulas. What will my units be? Will they give me the units of area like I expect? Let's calculate some areas here and see how we do. We maybe have a parallelogram like this. We said the area of a parallelogram is just base times height. Got a lot of numbers here, a lot of shape things. So here's my base. Notice it's the same top and bottom. So that would be 58 times the height. And I said the height is that perpendicular distance between the two legs. So we'll use the 43, not the 46. So the area of this particular parallelogram would be 58 times 43. I got my calculator here. That one's harder for me to do in my head. 2,494. Area is units squared, so that would be feet squared. So that would give me the area of that parallelogram. Let's try another shape here. A triangle. We have a few of those. So area, we said, is 1/2 base times the height. So for number 9 there, we'd have 1/2. The base is 9.8 yards. And the height is this perpendicular distance from the base up to the opposite point. So this would be 4.2. It's not going to be the 4.6 or 12.3 because those aren't perpendicular to the base. They don't make a 90-degree angle. Plugging that into my calculator, 1/2 times 9.8 times 4.2 gives me 20.58. And again, the units would be squared because this is an area, so that would be yards squared. For number 10, again, area is 1/2 base times height. The base would be the 8, or it could be the 3.5 actually. If this triangle were to rotate 90 degrees counterclockwise and sit on that edge, we could call the 3.5 the base and the 8 the height. It doesn't matter. You can rotate these lots of different ways and lots of times. As long as we multiply two of those that are at 90 degrees to each other, we'll get the same answer. So 1/2 of 8 is 4 times 3.5 gives me 14. And again, those would be square units. Now looking at number 11, I've got the 12 and the 13 that are not perpendicular to each other, but this other side is. To get that missing side, maybe I go back to that Pythagorean theorem that we've talked about. And remember, the C has to be the side opposite the right angle, so that's the 13. A and B can be either of the two sides, so let's call that one A. B will now be the 12. So I'd have A squared plus 144 equals 169. Subtract 144 from both sides, and A squared, well, I should probably write that down, minus 144 from both sides, and I get a 25. Now that's A squared. To find A, I'd take the square root of both sides, and I find that A equals 5. So that's my length, or my height of the triangle. So area is 1/2 base times height, which would be 1/2 times 12 times 5. 1/2 of 12 is 6, times 5 is 30. And again, that would be units squared. So now we've got the area of those three triangles. One of them we had to do a little math to find one of the sides, but we're pretty comfortable with that, so it wasn't too bad. Now let's take a look at a trapezoid. We said the area of a trapezoid is 1/2 the sum of the bases times the height. So we've got 1/2. The bases are the two sides that are parallel to each other. So we've got a 20.8 plus 10 times the height, which would be that perpendicular distance between the two. So 1/2 of 30.8 times 7 gives me 107.8. And again, those units would be squared because it's an area. So that's how we'll find the area of a trapezoid. About some application of this. I like pizza. Which one of the following is a better buy? A large pizza with a 16-inch diameter for $15. Let's see, there's 16 inches. Or a medium pizza with 8-inch diameter for $7.50. So maybe we find the price per square inch. So the area here, which is pi r squared. Now the radius is half the diameter, so that would be 8 inches. So this is pi times 8 squared, which is 64 pi. Now sometimes they want me to leave it like that. If they say in terms of pi, I leave pi in the answer. If they don't say that, then I'll do 64 times pi, and that gives me 201 square inches. So there's my area of the large pi. The medium sized has the same formula, only now the radius is 4 inches. So I've got 16 pi as the area. Again, in terms of pi, I would leave that 16 pi. I multiply those two together though, using 3.14. I'm actually using the pi button on my calculator. So we've got those two now. Price per square inch. Think about those words. Price per square inch. Per means divide, so I'm going to divide the price by the area. So for the first one, we have $15 divided by 201. That gives me 0.075, which is 7.5 cents. And the price per square inch for the medium pizza, see its price was $7.50 divided by the square inches. Gives me 0.149 or 14.9 cents. So the large pizza is definitely a better deal. Notice the diameter here was 16 inches and was 8 inches there. So we doubled the diameter and they doubled the price. That makes sense. It seems like it's the same thing, but when we do a price per area, they doubled the price per area too. So actually they halved, going that direction, going from the smaller to the larger, they halved the price per area. So definite difference there. It looks like it should be the same because you double the diameter, double the price, makes sense. But when you look at price per area, it's a different sort of problem. Maybe we've got something like this where they want the area of the shaded region. To calculate this, maybe I will find the area of this half a circle and subtract the area of the triangle. So the area of the semicircle minus the area of the triangle. Area of a circle itself is pi r squared, but I'm taking half of that because I only have half a circle there. Area of the triangle is 1/2 base times height. So we've got 1/2 times pi. I don't have the radius of the circle. I need to find that. And if I found this whole length, which is the diameter, I could get the radius, and that diameter is actually the hypotenuse of the triangle. So maybe a squared plus b squared equals c squared again. So 6 squared plus 8 squared equals c squared. Remember, c has to be the hypotenuse. I've got 36 plus 64 is c squared. That's 100. Take the square root of both sides. And the whole length is 10. So that means my radius is 5. Now the base and height of the triangle, notice how I said we could rotate triangles around? Well, we have two sides here that are perpendicular to each other, so those could be my base and height. Now, if they ask this in terms of pi, we would do half of pi times 25 minus half of 6 is 3 times 8 is 24. Oh, I did equals. It should be minus. I said minus, but wrote equals. So we might say 25 halves pi minus 24. In terms of pi, we might leave it like that. But if I wanted to round it and just type that in to the calculator, I would get 15.3 square inches. So we took the area of the semicircle and the area of the triangle and subtracted them. Like I said, sometimes we want to visualize things as if we've got one big unit and we're taking part of it away, and this seems to work that way. And that was the section on area. Now let's take a look at some volume problems. Volume is like how much water fits in your fish tank. So we're looking inside a 3D shape, and the volume of a shoebox or any box, any rectangular solid like that, would be length times width times height. Notice length times width would be the area of the base. And so sometimes we'll say that area of the base times the height. And we do that because we don't always have a rectangle on the bottom. Maybe we had a triangle on the end, like a Toblerone bar. Or maybe it's a circle, like that gives us a cylinder. So the area of that base times its height pretty well gives you the volume of any solid like that. So let's see, here we've got a length of 5 and a width of 5 and a height of 5. Oh, 5 times 5 times 5 is 125. That would be cubic inches. Notice this is a length cubed because we're talking about a volume. So we could say the area of this base here is 25. It's 5 times 5 times the height would give us the volume. Now, below that, we have a pyramid shape. And when they say height, they're talking about, again, this perpendicular distance to the base. So that's the 20 yards represents. Again, let's find the area of the base, which would be 8 times 15. Multiply that by the height, which is 20. But you know what? That would give us a shape that fills all of this area on each side. And we don't have that much. They've actually cut a bunch of that away. What they've cut away is 2/3 of it, and so they only leave a third behind. The volume of a pyramid is 1/3 the area of the base times the height. So we'll multiply all of this together. Let's see, a third of 15 is 5. 5 times 20 is 100, times 8 is 800. Those are the things I'll do in my head sometimes to try to speed up math. We can type that into our calculator, but if you can find a way to get a quick little calculation in your head, that'll speed things up. A third of 15 is 5. 5 times 20, we know is 100. 5 $20 bills is $100, and 100 times 8 is, of course, 800. So look for tricks like that that'll help. I mentioned area of the base times the height. Well, here's the, like I say, a cylinder. The volume equals the area of the base times the height, and the area of a triangle is pi r squared. Well, there's the volume of our cylinder. So we've got pi times the radius. Well, they've given us the diameter at the end. The radius would be half of that, which would just be 12. And the height would be that perpendicular distance from one base to the other, which is 21 inches. So 12 squared is 144. Times 21 would be 3024. And we still have that pi in there. So again, in terms of pi, this would be 3024 pi. We multiply those together in our calculator, we get 9,500 cubic inches. That's been rounded a little bit, but you can see how that works. Cone is just the same way as the pyramid was to the rectangular solid. We're going to take a third the area of the base times the height. So 1/3 pi times the radius, which they've given us is 4, times the height, which they've given us is 9. Again, a little trick here. 3 goes into 9 3 times. 4 squared is 16, and 16 times 3 is 48. We still have pi there. These will be meters cubed. If I plug in 48 pi to my calculator, I get 151 rounded up. Cubic meters. Again, rounded, but something along those lines. And so now we've got the volume of a cylinder and a cone. Maybe we'll put some of these together like when we were starting out. Maybe we have a cone with a hemisphere on top. The spheres are a little different. The volume of a sphere, just like the area of a circle was different from the area of a rectangle, this is quite different. The sphere is 4/3 pi r cubed. And again, that's one that is on the formula sheet. I don't know that it would hurt to memorize it, but it's there for you. So if we take the volume of the cone and add that to half the volume of a sphere, and we're doing half because this ice cream that's on top is really only half of the sphere. The sphere is like a ball. So the volume of the cone would be 1/3 pi r squared h plus a half of 4/3 pi r cubed. H is the 15 centimeters for the cone. The diameter was 12 inches. We need the radius, which would then be 6. So let's just plug all of those in. Let's see, half of 4/3 is 2/3. So 6 squared times 15 divided by 3 would be 180. So I've got 180 pi here. And 6 cubed times 2 divided by 3 would be 144. Both of those have pi in them. If I add those together, that gives me 324 pi. And taking that to my calculator gives me 1018 cubic centimeters. So you can see we can, just like with the areas, when we took multiple areas and added them together, we can do the same thing with volumes. Take multiple volumes and add those together. There's one last concept that they cover in section 10.5 that we should talk about, and that is surface area. Surface area is like how much paint would it take to paint this shape? And so maybe we'll treat it like areas where we're adding pieces together. Maybe I'll call this side 1, and we'll have side 2 and side 3. We'll have a side 4 on that edge, maybe a side 5 back in the left side there. Side 6 will be the bottom. And we could call side 7 in the back. Well, actually, we'll call 7 the front, and 8 will be the back. So now we can just take those various sides and add them together. So side 1 is a rectangle. So area would be length times width, 5. Now I need this width. Well, if we follow down, it looks like 4 yards is that same width for each one of those lines. So we'll just use that 4. So 5 times 4 would be 20 square yards. For shape 2, we've got length of 2 and the width was 4 for 8. For shape 3, you're 4 by 4, which is 16. I use this length of 4 times that width of 4. Side 4 is a height of 3 and a length of 4. Shape 5, which is this darker side on the left, would be 5 tall and 4 wide. Let's see, 6 we said was the base. So that side, which is 4 yards, times 9. Which is 36. Now we've got 7 and 8, which are both the same sort of shape. It's the front and the back. And so that's kind of a complex shape. Maybe I'll split that one too, like here. Then we'll have a 2 times 5 plus this full length, which is 9 times 3. Well, 2 times 5 is 10, 9 times 3 is 27. If I add those together, I get 37. And 8 would be the same, it's just on the back. And so I add all of those together, and it gives me the surface area, the area that I would need to paint if I had to paint this particular shape. And I ended up with 186. Remember, this is an area, so that would be squared units. So that is a useful thing to calculate. Sometimes we need surface area. Sometimes you need to figure out how much paint you need. One of the things they've done to us in this section, and it shows up in the homework for 10.5, but it's really 10.6 homework, and that's a little bit of trigonometry. So I want to go over that so you're familiar with it. And the stuff we talk about will only work with a right triangle. On your calculator, you may notice some buttons that say what looks like sin, cos, and tan. Those are actually pronounced sine, cosine, and tangent. And what we are looking at is the ratio of two different sides on a right triangle. So if I look from angle A's perspective, if I were to kind of look through the center of the triangle, I would get to a side that was opposite that particular angle. We already know that the side opposite the right angle is the hypotenuse. We use that in the Pythagorean theorem. And the side that's next to angle A, but isn't the hypotenuse, is called adjacent. Adjacent meaning next to. Oh, I forgot. Yeah, oh, I got it. Okay, so we've got opposite, adjacent, and hypotenuse. Sine of an angle, so the sine of angle A would be its opposite side divided by the hypotenuse. The cosine would be the adjacent side divided by the hypotenuse. Tangent is the opposite side divided by adjacent. So if I had a problem, again with the right triangle, that angle A, if they said that this angle was 35 degrees, for example, and they told me that this side length over here was a 7, and they wanted me to find the hypotenuse, then I could use this setup. Now that 7 is opposite angle 35. So we have opposite and hypotenuse, and that looks like sine. So we would say the sine of 35 degrees equals the opposite side, which is 7, over the hypotenuse. So now I need to solve for h, so I'd multiply both sides by h. This would cancel over here, leaving 7 equals h times the sine of 35 degrees. And then because I'm solving for h, I would need to divide by what it's multiplied by on both sides. Sine of 35 divided by sine of 35 is 1, and I am left with h equals 7 divided by the sine of 35 degrees. When I plug that into my calculator, 7 divided by the sine of 35 degrees, I get 12.2 as that length. So that's how we would use this type of problem, is just figure out which of those three, sine, cosine, or tangent, we need, and then set up the relationship. Let me do a similar one, again with the right triangle. Let's say this is 40 degrees, and they give me this side is 5, and they want me to solve for the adjacent. Well, opposite and adjacent, that was tangent. So the tangent of 40 degrees equals the opposite side divided by the adjacent side. Well, to clear the fraction, I would multiply by the denominator. Now I have a divided by a is 1, so that's why we did that. A times the tangent of 40 degrees equals 5. I'm solving for a, so I would divide by the thing it's multiplied by on both sides. Tangent of 40 divided by the tangent of 40 is 1, so I have 1a equals 5 divided by the tangent of 40. So I plug into my calculator, and I get 5.96. Now, it's very important that your calculator be in degree mode to make these work. There is another mode called radian mode, and it's not uncommon for your calculator to be in that mode to start. You don't want that mode. You want degree mode because our angle is measured in degrees. So make sure your calculator is in degree mode to make this work. But if it is, then these calculations will work out fine. Like I said, that's really a 10.6 calculation, but they put that in the 10.5 homework for some reason, and I forgot about it and didn't get it removed. So I wanted to make sure you were aware of how to do those calculations. Well, I hope this helps. If you've got questions, definitely reach out and ask. Have a great weekend.